Imagine a world without semiconductors. In some ways, this isn't hard to do since we don't usually see them. Semiconductors are materials that can be precisely engineered to control the flow of electricity. This allows them to have distinct on and off states, ones and zeros in digital speak, to allow digital information to be stored and conveyed. When you think about all that these tiny chips enable, phones, computers, appliances, it's hard to imagine living without them.
Maybe you knew your favorite devices harbor these powerful chips, but did you know that they are also essential for transportation systems? Semiconductors were first introduced in vehicles in the late 20th century to improve fuel efficiency and engine control. Since then, semiconductors are increasingly integrated into cars, trucks, planes, ships, and trains to enable microcontrollers, sensors, and power management circuits. They are also behind transportation infrastructure like toll booths and charging stations. These little chips help improve safety, efficiency, and performance of vehicles both inside and outside.
If you've ever seen a self-driving electric car, you've witnessed the current pinnacle of semiconductor use in cars. In fact, those little chips help power not only the flashy screens and entertainment features, but also the advanced driver assistance systems and battery management technologies that allow these cars to navigate our world autonomously.
Advancements in vehicles that use lots of semiconductors are enabled by many technological innovations working together, such as integrated circuit design, materials research, manufacturing processes, and supply chains. Semiconductor technology itself has also evolved significantly since 1874, thanks to decades of research by scientists and engineers. This ongoing exploration makes it possible to create smaller, more efficient chips that power modern vehicles.
In autonomous or semi-autonomous vehicles, semiconductors enable sensor technologies like radar and cameras. These sensors are the eyes and ears of ships, planes, and increasingly, cars. In self-driving cars, increased processing power of semiconductors allows them to compute vast amounts of data in real time to make decisions. Above all, semiconductors have become more durable and reliable, which is vital for transportation applications that require long service life under harsh conditions.
Technological maturity has driven the integration of semiconductors in transportation at a larger scale. Semiconductor manufacturing costs have decreased due to advancements in manufacturing techniques and economies of scale. Also, increasing environmental concerns and regulatory pressures are pushing for more efficient and safer transportation solutions, as well as for more eco-friendly materials of semiconductor manufacturing.
However, there are still challenges in integrating semiconductors in the transportation sector. For one, there have been significant semiconductor supply chain issues, delaying production and increasing costs for vehicle manufacturers. Also, it's been challenging to develop semiconductors that can reliably operate in the wide range of applications experienced by vehicles, like temperature extremes. Finally, as vehicles become more connected, securing them against cyber threats becomes increasingly important.
Navigating these challenges requires collaborative efforts from many different stakeholders, with the government being the key player. Through policy support, the federal, state, and local government agencies help shape the semiconductor ecosystem and transportation development. For example, the National Science Foundation developed the Future of Semiconductors program to bring together government agencies, academia, industry, nonprofits, and even international partners to address the R&D needs that will shape the semiconductors of the future.
One reason governments prioritize semiconductor development is because they support economic and national security. Military vehicles and equipment also rely on these small chips to function. In 2022, the U.S. passed the CHIPS and Science Act, encouraging not only technological advancements, but also security and sustainability of semiconductors.
Universities, one of the major beneficiaries of funding, play a key role in developing these microchips to benefit society. We spoke with Dr. Hongbin Yu, the director of ASU Center for Efficient Vehicles and Sustainable Transportation Systems, who emphasized the interconnectivity of government, industry, and academia.
I'm the director for the National Science Foundation's, they call it Industry University Cooperative Research Center. So the center it actually has 4 universities: ASU, University of Louisville, Alabama, and the University of Texas at Austin. And the goal for that center is actually trying to put together faculty from these 4 universities to work on the research topic of interest to industry, right? Because Industry University Cooperative Research Center. Kind of throughout the last number of years, we have car OEMs like Ford, GM, right? And Mercedes-Benz, Toyota North America, but also we have suppliers like Cummins, which make engines, right? For a lot of them battery internal combustion engines.
Universities are key for bringing together government agencies and industry to advance innovation. Daniel Ho, a technical marketer at NXP Semiconductors, can give us firsthand industry perspective on this.
Universities are providing a lot of research resources. We're coordinating with the students to actually, we also want to learn, what's going on in the academic world, right? What's the newest technology there? Part of that R&D is, to coordinate projects that's led by the students and our engineers.
It takes industry, academia, government, and nonprofits working together to revolutionize how we perceive mobility, affordability, and infrastructure development. But there are still questions to be answered. On the one hand, having more semiconductors in vehicles is pushing up their prices. On the other hand, semiconductors could provide huge cost savings in infrastructure. Imagine a scenario where, at the press of a button, your car aligns itself with the flow of traffic, optimizing speed and spacing to eliminate traffic jams. Then, instead of pouring trillions of dollars into expanding highways, governments could redirect that money towards essential maintenance. Thanks to semiconductor-enabled vehicles that communicate and synchronize to use existing roads more efficiently.
By leveraging innovations like these, we could decrease the cost tied to, say, car ownership and road usage, making transportation more accessible and sustainable. Yet, as we embrace these technological advancements, we should also comprehensively evaluate and understand their impacts, while equally considering the economic, environmental, and sociocultural factors at play to avoid unintended consequences.
All stakeholders need to work together to navigate these complexities and potential challenges ahead. As we continue to explore the transformative potential of semiconductors in transportation, we must remember that this technology is embedded with human values, norms, and preferences. With appropriate foresight and management, we can work towards building the future we want to live in.